the variables modified by const have read-only, essentially variables. The local variables that const adorn are decorated allocate space on the stack. The const decorated global variable allocates space in the read-only store. Const decorates the variable, which simply tells the compiler that the variable cannot appear to the left of the assignment symbol. Const can't define a true constant. In C, let's look at an example.
In test.c program, we define the const type C, initialize to 50, then define pointer p, and then initialize the address of C pointer p. Well, we generate executables through the GCC compiler. C is 50 or 5. Let's verify it. We found that the value of C has been changed to 5, we modified the value of C by pointer p. Let's compile the program with a G++ compiler. Isn't it strange that we found that the value of C has not been modified? Let's analyze this program. In the C++ language, symbols decorated with const are true constants. Constants enter the symbol table, and when constants are used, the compiler takes values from the symbol table. Maybe smart you have another question: why does the constant have an address? So let's go into deep thinking. We modify the pointing memory space to 5 through pointer p, and finally through pointer p5 can also print out, because the pointer p points to the space is obtained by C, but this space and constant C is not the same, they are two things. Smart you have to start to question, why make it so complicated? Because this is supported in the C language, it is also supported in C++, in other words, in order to be compatible with the C language. When using constants in C++, you may produce corresponding variables, such as we have code const type name. Direct use of name can get the value of the constant. If we use code to take the address name, this address points to the memory space as a variable. The constant will go into the symbol table, cannot be changed. Variables will be stored in memory when using constants in C++. You may produce corresponding variables, such as we have code const type name. Direct use of name can get the value of the constant. If we use code to take the address name, this address points to the memory space as a variable. The constant will go into the symbol table, cannot be changed. Variables will be stored in memory. Maybe you think of macro definitions. This constant is very similar to macros. Oh, then they are the same? Let's start by analyzing the differences between them. Constants are handled by the compiler. Constants can be scoped and type-checked. Macro definitions are pre-processed operations. Just text replacement. Is not constants than macro definitions a lot more? This is obvious. But let's look at an example. In the f function defined macros and constants, printed them out in the g function. We called the f function and g function in the main function. This is our program. At present we only print out macro a. Do you think the compiler will report errors? Let's test it through the G++ compiler. We found that macro-a is printed out, which shows that macro-a is not scope concept. In other words, macro-a scope and global variables are equal. Let's modify our program. The constant b also printed out. Smart, you are not full of questions. This should not be possible. Let's test it. Line 12 code misstated, and we failed to compile because constant b is a local constant of function f and cannot be called in G function. This code shows that macro definitions are different from constants, that constants are scoped, and that macro definitions are not. In the C language, const is decorated with a read-only variable. Const is decorated with a constant in C++, but this constant allocates storage space during use, and if this is a global constant and used in other files, or if an address symbol is used for a local constant, the storage space is allocated, but the space is not necessarily used. Finally, in the C++, const can define the true sense of the constant. In the process of using constants, the compiler can allocate storage space, but we do not necessarily use this storage space. Const keyword, you understand how? I hope you can like my analysis.